Picture this: you're an astronaut who has just landed on Mars after years of intense training and countless sacrifices. You're ready to share your monumental achievement with the world on TikTok. But there's a hitch: you can't get a signal. While it might sound like a scene from a sci-fi movie, the reality is that establishing internet connectivity on Mars is a genuine necessity. It's not just about astronauts updating their social media or browsing the internet. The sheer volume of data that needs to be transferred between Earth and Mars for a human mission is immense, and it's a challenge that we need to address. So, how can we build a reliable information network on Mars that can handle both logistical and personal communication needs? A recent research paper on the Archive preprint server offers a potential solution. The idea of an interplanetary internet isn't new. Astronauts aboard the International Space Station already have internet access, although it's slow. But providing internet connectivity to Mars presents two main challenges. Firstly, there's the issue of bandwidth. We can't just lay a fiber cable from Earth to Mars. Data has to be transferred via radio signals. Currently, our communication with Martian satellites and rovers is handled by the Deep Sky Network, DSN, a global network of large radio antennas. But the DSN is already stretched to its limit, and we haven't even launched a manned mission to Mars yet. The paper suggests a solution: edge computing, the same technology that enables you to stream services like Netflix and Disney+. The idea is to distribute servers to enhance speeds and share the load, so no single server gets overwhelmed. The authors propose creating a network of satellites around Mars, with 9 satellites in each of 9 orbital planes, making a total of 81 satellites. These satellites would communicate with each other, providing redundant backups of data. This would ensure that various landing sites on Mars could communicate with 2 or 3 satellites at any given time. For longer missions, ground-based servers could be used for even quicker data access. Building such a system would be expensive, so the authors suggest constructing the satellite constellation in stages. As preliminary missions to Mars pave the way for a manned landing, a few constellation satellites could be included. By the time we're ready to build long-term stations, the satellite constellation could already be operational. So, when you finally step foot on the red planet, the internet might be ready and waiting for you. Now that's a future worth getting excited about.